So now that we know what an object is and the different portions that make up an object, what we need is referred to as a class diagram. If you flip over to page 194, we have the generic example of a class diagram there. Every class diagram, now what I will tell you is, before we get into the meat and potatoes here, that absolutely positively, irrespective of the language it is that you are going to be actually deploying your program or your procedure to. So whether or not this is, this is going to be Java, this is going to be a C++, this is going to be a C#, this is going to be in Android or iOS development. The idea of the class diagram is universal. So what we see here on 194 and the preceding, or the subsequent rather, pages is universal. The class diagram is universal. At the very top of the class diagram, we would have the class name. So in the example we see here in the text, it would be car. Potentially it would be truck. It would be motorcycle. That lets you know that we are going to have objects that are going to be related to this. So that goes at the very top of those three conjoined boxes. The middle there is a listing of all of your attributes. It does not matter how many attributes you have, you put them all in here. So if your object is a simple object that only has 3 or 4 attributes, that's fine. If your object is a massive object that has hundreds of attributes, that's more complicated, but it's fine too. On the very bottom portion of that box we see here in the class diagram is a collection of the methods. The same deal is going to be involved here. There is no lower or upper bounds for how many different methods you want associated with an object. The larger your program is, the more likely it is that you have more methods associated with your program. That is not a big deal. So as we continue over to page 195, at the very top we have the class diagram for car. So again, the rules here all apply. On the very top of the class diagram we have the name of the class, and that's car. Underneath that section we have the attributes. Make, model, doors, body length, engine size, color, speed. I would suggest to you speed is maybe not the best attribute name. It doesn't exactly tell us in clear, concise, and unambiguous terms what the heck it's looking at here. Top speed would be better. Average speed, I would argue, would be totally useless, but even better than speed. We do still want to stick to our naming conventions here and the reasons for our naming conventions here, because when we hand this off to the next developer in the chain, we want everything to be as clear and concise as possible. The next box, or the section rather, of that box underneath there is going to be the methods: accelerate, stop, brake, and turn. And you will notice that turn, like we saw in the previous class session, is actually going to receive a value. So we're going to pass a parameter to turn, and that is going to be the direction. So that's perfectly clear to us. Direction means, and I'm not sure how I can use this without using the word. It is going to be the direction that we're going to turn. So we would pass the method turn either a left or a right, and we would go from there. So if you think to your parking in the parking lot example, that's actually what we would need to do in order to get into a space or get into the parking lot or come in off of Mulford, etc. Now that we have classes, we can have individual objects of those classes. So what we see here on kind of the bottom of 195 is 2 instances, 2 uniquely identifiable, one-of-a-kind objects that happen to what's called inherit. They they derive themselves. I should explain myself there. I think for those of you here that have been born in the Midwest, when I use the word inherit, I think that very probably you want the word inherit. I will, from here on out, try to do my best to remember essentially to translate that for you. But if I don't, just think to yourself, Eric talks funny, and that's perfectly okay. So these two instances of an object, they're both cars, because both of these inherit from, I did it again, car. So the example we have on the left of the Ford Falcon, you will notice that in the name for that particular object, we have given to it a unique identifying number, RVJ635. We need that unique identifier in order for this whole system to actually work. For those of you who are going to go either into a database design class or actual database design thereafter, this is going to be known essentially as the primary key. It is going to be a unique identifier that every new record or every new object gets a new unique identifier. So even though Ford Falcon is a frankly unmitigatingly shitty car, there are many Ford Falcons, the rest of them that haven't exploded and killed their drivers and passengers along with them. But this particular car, RVJ635, is mine. So it belongs to me. It's the one instance of this, and I can actually point to that particular object and say, I've made a huge mistake because this is my car. You'll notice it absolutely positively has a number of doors. It has a body length. It has an engine size. It has a color, and it has a speed. 0 here is actually entirely correct. It also has, as you can see there in the very bottom of the class diagram, accelerate, stop, brake, and turn with direction. So what we're saying with inheritance here is that every new instance of an object that comes from a class has access to all of the attributes and all of the methods that are defined in that class. We've got another example there, SVU 478. This is also a car, so that SVU 478 is its unique identifier. This time it's a Toyota Corolla, and a much better decision than a Ford Falcon. And you'll notice the same exact set of attributes and the same exact set of methods that belong here. So what we're saying is that it doesn't matter if you are getting a Toyota Corolla, a Toyota Avalon, if you are getting a Ford Falcon or a Ford Fusion. Those are all cars, and they all derive everything that is similar from car. They all inherit that down from there. This makes things really easy when we are developing a large platform or a large application. So what we're saying is, as this car goes from one system to another, or as this car, would interact with the methods that are driving, or the methods that are parking, or the methods that are, anything that goes together with having a car. We would simply essentially push this object there, and we can interact with this object because wherever that object goes, it has those exact same attributes and it has those exact same methods, and we know how to be able to interact with it.